start to do chapter 4, review question, free response number 2. So for this question, we're giving the 25 milliliter of 1.50 molarity of K2CrO4. Okay, remember from the class what we said, when you said volume and molarity, you can always find more. So you know that this, I'm gonna find more. Okay, with 15 milliliter of 2.5 molarity, same thing here. That's gonna give me more of FeNO3. This is more of K2CrO4. First step, write the balanced chemical reaction. Okay, A K2CrO4 plus AQ, we know it is AQ, FeNO3, 3. AQ, go to. This is gonna be double displacements without anything set. We're just gonna switch K and Fe. So Fe, gonna go with CrO4, okay? And then K is gonna go with NO3. Now please don't balance yet. You're gonna look at the things first. CrO4 must be -2 because K is a +1, so 2 of them, so that's -2. Fe here must be +3, sorry, +3 because NO3 is -1. -1 times 3, -3, and then Fe is +3. So +3 -2. That means we're gonna balance that. 3, 2. Okay, now my things are balanced. K is +1, NO3 is -1. That's good. Now you gotta balance left and right. Let's see. 2, 1, but then there's 3 here, CrO4. So we're gonna do 3 there. That make it 6. Okay, let's put 6 there. NO3 is 6. That's 3, 2. Fe is 2, 2. You should have done like this. Now, if you want to put the stage of matter, this is solid. This is AQ. Because remember, this is AQ because nitrate is very, very soluble. Okay. Now, if you do not know how to do it, you don't have to put it there. But that's what it is. Okay. We're balanced. We're done with this. Part B. How many grams of precipitate form? Before we get to that, first let's go ahead and find the mole of my reactant first. So I'm going to go through the mole reactant. 1.50 molarity just means mole over liter. That means careful. Time liter. 0.025 liter. Okay, that will give me mole of K2CrO4. I'm going to do the same thing. 2.50 mole per liter times 0.015 liter. Again, we are using liter. Mole of FeNO3, 3. Okay, let me go ahead and figure it out. Actually, technically, you can do without using it because it's 25 times. But you got a calculator, you can try it. Right. So let me see. 1.5 times 0.025. We're gonna get 0.0375. So 0.0375. Okay, and then the next one, I don't know if you notice, is the same number. Okay, this times this, you're still gonna get 0.0375. If you don't believe, you can try calculating. All right, I'm gonna try that. Yep, 0.0375. Because, right, you're just literally doing 25 times 15 decimal. You can see that that 2 decimal place plus 3 decimal, that's 5 decimal place. It's the same thing, right? So next, what we're gonna do is we're now gonna find the gram, right? Remember, we're not there with the question yet, so we're gonna go back to question. So we're gonna say 0.0375 mole of K2CrO4. Make sure correct side. Mole of K2CrO4 on the top, mole of precipitate, so that means we're looking for this, Fe, 2CrO4, 3. Alright, and then gram, because they want gram. Now, you can leave it in the mole and find grams later, or you can continue. So I'm going to just go ahead and find gram. So time, moles, grams. Remember, this is Fe2CrO4, 3. Okay, you're gonna get an answer. You're gonna do the same thing because you don't know, right? Technically, you do know. You don't need to find both of them. Here's a reason you don't know. Take a look at both of them. They're the same mole, right? Look at here. You need 3 of this and 2 of this. So that means you're gonna use more of this to make this product. Since they're both the same thing, you know that K2CrO4 is a limiting reagent. So if you want to find limiting reagent, if I were asking you to find limiting reagents for this question, technically you don't need to do this. You can just reason based from balance equation and then say explain it. Or you do this and then tell me that because it's get the smaller number, it is the limiting reagents. Either one of them will work. Make sense? Okay, let's take a look. So I already kind of know it. I don't need to do another guide, so I'm not gonna do the next guide. If you want to, you can go ahead and also convert FeNO3 3 all the way to Fe2CrO4 3. You will see that this one will give you a smaller number, but I'm not gonna do it. Okay, so this is 3. This here is 1, which is based on this. This is 1. I'm gonna do Fe2CrO3 for 3. Okay, Fe2. Fe is 55.85 times 2 plus Cr is 52 times 3 plus O is 16 times 3 times 4. All right, so that will give you 459.7. Multiply, divide. Time 0.0375 divided by 3. 5.746. This is my answer for part B. Okay, so if you're wondering, you could definitely convert the other one also, and you'll see that it will be less. In fact, let me see, what would that number make you? If you use this FeNO3 to figure out Fe2CrO4 you're gonna get 8.6. So definitely would make more, which is not possible. This is my limiting reagent or reactant, either way, right? K2 is limiting. Now let's talk about calculate the concentration molarity of all the iron at the end of reaction. This kind of go with the drawing too, so I'm gonna do both so that you can kind of see that. So part C, let's talk about which one's left at the end. So end of reaction. Remember I talk about end of reaction. Of course you're gonna have your product. You're gonna have Fe2CrO4 solid. So this is not iron. We're not gonna talk about this one. You also have KNO3 at the end of reaction, but this is aqueous. What does that mean by aqueous? That means it's gonna break into K plus and NO3 minus. It's gonna definitely break into these two pieces, right? And then you have excess. Your limiting was, right, K2CrO4. This is a limiting, okay? So that means it is used up. This is gone. Now, one other reactant left, FeNO3 3. This is excess, leftover. Right? So, how are we gonna do this? Well, this is a leftover. We need to figure out how much is left over on here. Okay, so how much is left over? Well, let's see. Go back to this. You can do the ratio. We know this is how much it's gonna use. So from there, you can figure out how much of this is gonna use. Perfect. 0.0375 mole of K2CrO4. This is used it amount. Okay, time 3:2 ratio. 3K2CrO4 equal to FeNO3 3. I'm gonna get an answer. That is how much used. Okay, 0.0375 times 2 divided by 3, 0.025. 0.025. Okay, this is still not molarity yet. Fe NO3, 3. Okay. To find molarity, you just need to know how much volume of liquid there, and then you can just divide it, you find molarity. But notice that you can't divide it to this yet, this is used. So you need to figure out leftover, right? Which means how much it start out with, which is up here, right? You have 0.375 mole Fe NO3 3 minus 0.025 mole, right? So that's gonna give you 0.350 mole Fe NO3 3. Okay, I believe it was 0.35. Okay, yeah. This is how much. Now let's talk about concentration of Fe NO3 3. You want to find it? It's easy. The mole divided by liter. Where are you gonna get liter? Go back and look. It is 0.025 plus 0.015. Remember, both milliliter added together. So this is 0.35 divided by, I'm just gonna go ahead and write M, 0.404. Okay. .75 molarity. Okay, now I'm gonna find out the rest. From there, I can write out Fe plus 3. Since FeNO3 3 only have one Fe, it's gonna be 8.75 M. Go to NO3 minus 1. Since NO3 has 3 of them, you're gonna do 3 times 8.75 M. So you're gonna get 26.25. You're gonna do the same thing with the other one, how much KNO3 is being made, okay? Which again, you can use this top number to figure out, because K2ClO4 is limiting reagents. So I'll go there. 0.0375 mole K2ClO4 time K2ClO4 is 3 mole. Followed by on the top is 6 mole of KNO3. Okay. That just means time 2. Right. 0.075 mole, which means divided by liter, which is 0.04. Remember, it's the same volume, right, of liquid floating in there. So that's gonna give me 1.875 big M. Since K and NO3 has the same amount of letter, this concentration is the same thing as concentration of K plus, which is 1.875 M, and also concentration of NO3 minus 1, which is 1.875 big M. Oopsie, I don't know, I'm trying to box it. Now, what's gonna happen is, you notice the individual ion. You have 3 ion, Fe, NO3, and K, but you see NO3 happening in 2 places. You gotta add them. Concentration of NO3 minus 1, don't forget that minus 1, equal 26.25 plus 1.875. Okay, so that's gonna give you 28.125. Alright, so the correct answer, I think my computer will stop. Hoping it's still recording. I think it is. Alright, so computer kind of slipped up earlier. I don't know if it got recorded. If not, all I was doing is K2CrO4 and I calculated into mole of KNO3, and then from there divided by total volume to get the molarity, which is concentration, and then I break it into two of them, K and then NO3. Now NO3 I need to add up with because the previous one is also NO3. I add it up, I get it here, and then my Fe is here. So these are my three answers for the question number 4C. Now, if you're looking for the answer in terms of drawing, you can also draw these in as easy. You're just gonna draw a solution, okay, and then you're gonna draw some kind of dirt on the bottom. That is Fe2CrO4 3, the one that is not soluble, okay. And then you're gonna draw plenty of liquid there. That's a liquid, and then you're gonna draw the rest of the iron. So the rest of the iron being is you're gonna draw Fe, okay, and then you're gonna draw K, and then you're gonna draw NO3. Okay, you can see based on the number, even you know that K is less. If you're not sure, you just draw. For every K, you're gonna draw a big gigantic, a lot more, and one NO3, right? K and NO3. You're gonna draw Fe. You're gonna need to draw NO3. Now, for each Fe though, you can't just draw one. You gotta draw three. Right? Something similar to this. Now, can you draw multiple FeNO3? Yeah, you can. Just put it in there. Okay, if you will draw according to scales though, you will see that there is about 4 times as much Fe compared to K. So you need to draw 3 other Fe and 9 other NO3, which I'm not gonna draw this. Okay, this is pretty much what it is for full free response.